Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to learn how to draw a cam profile of a knife edge follower with uniform velocity, and condition is that here offset follower. When the axis, in this case, the axis of the follower does not pass through the center of the cam. That is the meaning of offset. But in this session we learn how to study how to draw the cam profile for two cases. Case one is that the axis of the follower is passing through the center of the cam, and another case is that the axis of the follower doesn't pass through the center of the cam. This is the center of the cam. This is non-offset case. That is the case one. Case two is case 2. This is offset. The axis of the follower is not passing through the center of the cam. This distance is called offset distance. In these two cases, how to draw a cam profile? Okay, so let us begin. We have to draw a cam profile for the given conditions. Here the type of follower is knife edge follower, and outstroke during 60 degrees of cam rotation, dwell for the next 30 degrees of cam rotation. That is called during outstroke, dwell. After the outstroke there is a dwell of 30 degrees of cam rotation, and return stroke. During return stroke, 60 degrees of cam rotation is the return stroke, and the dwell for the remaining 200 degrees of cam rotation. Here the outstroke and return stroke are equal, that is 60 degrees of cam rotation, but dwell during outstroke is 30 degrees and return stroke is the remaining angle. That remaining angle is the 210 degrees of cam rotation. The dwell is very high. So when dwell is high, we have to understand that portion, the 210 degrees of cam, that shows the minimum base radius of the cam. That is that portion is. Now during that portion the cam doesn't move. It remains same position for the time period of for the angle of rotation of 210 degrees. Now the stroke of the follower, it is the stroke or lift of the follower is 40 millimeters, and the minimum radius of the cam is 50 millimeters. Now the conditions: the follower moves with uniform velocity during both the outstroke and return strokes, and draw the profile of the cam when the axis of the follower passes through the axis of the camshaft, passes through the axis. It actually passes through the center of the camshaft and passes through the axis. Okay, and the axis of the follower is offset by 20 millimeter from the axis of the camshaft. This is the case 2. This is the B case A. Yes, according to here given. Now before drawing the cam profiles, what to do? We have to draw the displacement diagram of a knife edge follower with uniform velocity. That is the condition. This is the uniform velocity during both outstroke and return strokes. Now how to draw this displacement diagram? We have to consider Outstroke theta O 60 degrees, that is 60 degrees, and theta OD, that is 30 degrees, theta return stroke, that is 60 degree, and theta return dwell, that is 210 degrees. So convert this into a square, that is in order to draw the displacement diagram with uniform velocity. Now take a scale. To draw the displacement diagram, we need both x-axis and y-axis. And axis x scale equal to, consider it 10 degrees equal to 1 centimeter. Then on y-axis, this is x-axis, scale on x-axis. X-axis represents the rotation of the cam rotation. Okay, and y-axis, what is the y-axis scale? The lift of the follower, what is how much? The stroke of the follower is 40 millimeter. That is 40 millimeters. That is considered as a scale, that is 1 centimeter equal to 1 centimeter. That is the y-axis. So draw the diagram. Now then in that case, then 60 theta degrees, theta O, outstroke becomes how many centimeters? 10 degrees equal to 6 centimeters. 10 degrees equal to 6 centimeters, then 60 degree becomes 6 centimeters. Then theta OD, 10 degrees equal to 1 centimeters, that is 30 degrees becomes 3 centimeter. Theta R, the theta R again, return stroke, that becomes 6 centimeter. Theta RD, return, that means dwell during return, that is 21 centimeters. So draw a square with the length of the total sum of the lengths at a straight line. Draw a line. That line is total length. What is the total length is? 6 plus 3 plus 6, that is 15. 15 plus 21, that is 36. So with the 36 centimeters, draw a length x-axis and draw a vertical y-axis line. Vertical line, that is what is the length of the vertical line? That is lift stroke, that is 4 centimeters, that is 40 mm. That is 4 centimeters. This is 360 millimeter, 36 centimeters. Divide this, complete the rectangle. Next, divide this rectangle into the partitions in relation to outstroke and dwell during outstroke, return and dwell during return. The theta O, that is 60. And it is a dwell, theta D, that is 30 degrees. Then next, divide this into again. What is the next one is return stroke, 60, that means 6 centimeters. That is theta return, that is 60 degrees. The remaining is 210. So it is so long that dwell we have within the displacement diagram, dwell doesn't have that much effect. It becomes a horizontal constant line. So that what generally we'll do, we'll draw a line of this one. The remaining portion shows dwell period. This is the dwell, complete portion. That is theta return dwell. That's 210 degrees. So it is a huge 36 centimeters. During answering this question and drawing a displacement diagram, it crosses the border of your answer script. Then make it. Our requirement is theta outstroke or theta O, theta OD and theta R. And theta RD doesn't require that much in order to draw because it is a dwell zone. So no need to extend because it crosses the answer script page. Now, Now divide these equal parts into equal even number of parts, either 4 parts or 6 parts and 8 parts. So generally we follow 6 parts, which is optimum division. So if you divide number of even number of parts, the more clarity comes. Okay, more accuracy will be improved. And one more thing is that when accuracy improves, and also it takes time, if the number of equal number of parts are more and more. So that's why the optimum, neither 2 nor 4. Similarly, neither 8 nor, but we are following only 6 equal number. That means it takes time and also maintains optimum accuracy. Now, this theta O 60 degrees should be divided into how many parts? 6 parts. So divide this equal number of parts. So what is the length of this theta? That is 6 centimeters. So the 6 centimeters can be divided easily. So I am drawing here freehand, but you have to use it instruments: scale, protractor, compass, pencil, eraser, and all. Yes, with these instruments we have to draw. So I am giving here the procedure how to draw the cam profile. Okay, so then after drawing, this is what we'll get it. We'll see it now. Divide into equal number of parts. How many parts? 6 equal number of parts. 0, 1, 2, 3, 4, 5, 6. Divide this and join equal number of parts. Okay, like that. This is the shape how it comes again here. Draw a horizontal line. I am here, I am representing, I am showing here. First step, this is the first step, step 1. Then this is the vertical line with the dimension of lift, step 2. Then complete the boxes with the step 3. Okay. After completion, what to do? The 60 should be divided into 6 parts. 1, 2, 3, 4, 5, 6. This is step 4. Similarly, return stroke. You also divide return strokes with the equal number of parts. That is 0, dash, 1, dash, 2, dash, 3, dash, 4, dash, 5, dash, 6, dash. It depends upon you. Some other books they follow 6 dash, 5 dash, 4 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, 0. So some other books follow 6, 7, 8, 9, 10, 11, 12 like that. It is up to you. Okay, but the meaning is that we should follow the notation, whatever notation may be. The principle is that you have to divide into 6 equal number of parts. Now, after dividing this, that is the fifth step. Then it is the uniform velocity. The follower having a motion of during outstroke and return stroke is uniform velocity. So it is a straight line. So mark this AS is outstroke, that's 60 degree. ST is the dwell during outstroke, and TP is the return stroke angle, that is 60 degree. Remaining 210 degrees is the dwell during return. Now join from A to G. Join A to Z. Okay, and GH. Join GH. And directly, because during outstroke it is a straight line, uniform velocity becomes mixed straight line. And also what happens, it is HP. The HP is a straight line. HP is the straight line. Okay, now join the straight lines. This is the curve, the displacement curve. Again, AG, GH, HP, and it is X. This red color curve represents the displacement curve of a follower, knife edge follower having uniform velocity. Uniform velocity. Alright. Now, this is the displacement diagram. The follower, knife edge follower having uniform velocity, for a rotation of the cam of outstroke 60 degrees and a dwell during outstroke 30 degrees and return stroke 60 degrees and dwell during return stroke is 210 degrees of cam rotation. Axis X represents cam rotation. Axis Y, AY represents stroke or lift of the follower. Here it is knife edge follower. That's why we are following stroke or lift of the knife edge follower. Okay. After drawing this displacement diagram, we have to draw the cam profile. Okay, that cam profile. Let's begin. The cam profile looks like that. But how to start this? Step by step. So I covered up to 4th step and 5th step in displacement diagram. What is the next 6th step? Join AG. After joining AG, this is the AG, the 7th step GH, and HP is the 8th step. And join P to X, that is the 9th step. So with these 9 steps, you can complete the displacement diagram of a knife edge follower having a motion of uniform velocity. Now, it is the cam profile. I'm going to describe you first. This is the red color curve represents the cam. How to start this cam profile? I'm going to start. First, draw a base circle radius, minimum radius of the cam. That radius of the cam is given as 50 millimeter. With the radius of the cam, draw a circle. With the help of the compass, draw a circle. Now here we are drawing the case A. What is the case? First case is the axis of the follower is passing through the center of the cam. Okay, passing through the center of the cam. For that, we are drawing. That is the case 1. Now, this is the point of starting the passing through center O. That is the first step. Step 1, drawing the base circle. Next, what is the next step? Step 2, marking the point of the center of the follower, axis of the follower passing through the center of the axis of the passing through the center of the cam. That is the step 2. Next, step 3, divide this base circle. The total angle is 360 degree. That should be partitioned with the divisions given. That is outstroke angle of cam rotation. After that, the dwell, next return stroke and dwell during return. Divide this complete base circle into the given outstroke cam rotation, outstroke, dwell, return stroke angles. Now, the angle of outstroke angle is how much? It is 60 degree partition. Okay. Next, what is the next part is? This is 60 outstroke, theta O. Next one is after next to that immediately return. The no dwell. That dwell is 30 degrees. Next, after the next portion is 60 degrees during return. Again, return stroke angle of rotation is 60 degrees. Next, remaining angle is, this is return, dwell during return. That is 210 degrees. Okay. That is the third step. Third step is partitioning the base circle with the given outstroke, dwell and return stroke and during dwell during return stroke angles. We have to partition. That is step 3. Next, step 4. The step 4 is that divide this outstroke partition of angle of partition of base circle with the equal number of divisions. Same what you have done for displacement. In the displacement diagram, we have divided into the outstroke into how many parts? 6 parts. The same number of parts it should be divided. the base circle outstroke portion also, partition also. So we have divided, what is it, is a 60 degree by 6. How much? 10 degrees. Each partition should be divided and marked and draw a radial lines. This is point step 4. The step 4 is dividing the outstroke partition of a base circle with the equal number of divisions. What we have divided in the same as number of the displacement diagram divisions. Outstroke is 6. So here also you have to divide 6 parts, equal parts. How to do it? With the help of protractor. Keep the protractor here. All these divisions we can do it. We can mark it and join the marked points. Now, next, dwell, there is no division. Then return stroke having 6 equal number of parts. Divide this again into 6 parts. That is 0. That is 60 degrees. 60 by 6. That is 10. That means 10 degrees each part. And mark with the points 1, 0 dash, 1 dash, 2 dash, 3 dash here, which was here. Same number of partitions. That is 6, 6. Draw a radial lines passing through those marked points. Okay. Then what to do? Next step. That is the fourth step. Fourth step is dividing the outstroke angle of rotation of the cam of a base circle and also return stroke angles with the equal number of divisions which is divided in the displacement diagram. The next step is what we have to do. We have to measure the distances from 1 to B from the displacement diagram. This is the portion. This 1B distance you take and come back to here. The distance, which point? Come back to the diagram base circle. I am going to change the color. This 1B is there. Mark it 1 to B point. Next 2 to B. 2C. 2C. 1B 2C. Coming back to base circle 2 and mark the point here. That is the C. Next 3 to D from displacement diagram. Yeah, from coming to, you have to mark 3 is the center. With the help of the compass, D. Trace the point. Next, there is a 3D. From 4 to E, this is the distance. 3D, it is a 4D. In the 4D, from 4 to E, from 4 in the base circle, on the circumference of the base circle, keep the compass here and mark the distance of the radial line. Mark it. 5 to F. 5 on the radial line on the circumference of the base circle of the cam and is the E. Next, 6 to G is the 6 on the circumference of the base circle and chop the arc, that is the 6G. Okay. Next, what is the next step? Similarly, we have to follow the same procedure for outstroke also, for return stroke also. The return stroke points from O dash to H. This is the O dash to H. The O dash to H, mark the point. Next, 1 dash to G. This is 1 dash and it is G. Next, 2 dash, 1 dash to J. 2 dash to K. This is the 2 dash and it is K. 2 dash to K. Next, 3 dash to L distance. Take the 3 dash to L with the help of the compass and mark this 3 dash to L. 3 dash to L. Next, 4 dash to M. This is the 4 dash and it is M. 4 dash to M. Next, 5 dash to N. From this is the 5 dash and base circle and it is N. 5 dash to n. 6 dash, we write our 6 dash here. And the remaining portion is the dwell. Dwell means there is no need to divide anything. It is the constant. Now, join all these marked points with a smooth curve. The curve I am using here, start drawing from 1A to C, C to D, D to E, E to F, F to G. And again it is G to H, H to next point, J, K, L, M, N, P. This is the portion. Then what is the next portion is? The next portion is the dwell zone. The dwell zone is the remaining constant radius. That is, here it is base circle, minimum radius of the cam. Okay, this is the curve, cam profile of the cam. So this is only the profile of a cam when the axis of the follower is passing through the axis of the cam. Alright, that's what we have studied here. Now what to do? This is the, now what is the circular lines here? That circular lines no need to draw. These are the representing the intersection points. The maximum circular line, what will happen? The maximum length, this is the H. The distance from each circle A, B, C, D here in these points, axis. This is the stroke of the follower. The total distance, last two from point to contact of the cam to the distance, this distance measures should be equal to the lift of the follower. That should be 40 millimeter. What is the maximum radius? In the minimum radius 50 millimeter. The maximum radius is 50 plus this distance lift, 50 plus 40. That is 90 millimeter. 9 centimeter is the maximum radius. So this is the case. This is a profile of the cam when the axis of the follower is passing through the center of the cam. Now another case study. Another case study that very important. We have to draw the offset by 20 millimeter from the axis of the camshaft. What is the offset by? That means let me start drawing first. What is the displacement curve? The displacement diagram remains the same because it is related to the cam rotation and also follower. The follower is having uniform velocity. The same follower it is, okay, the same displacement diagram. The follower is knife edge follower and having a motion of uniform velocity. Now the condition is that when it is offset by 20 millimeter, that means the rotation, the axis of the cam is not passing through the center of the cam. Marked by axis of the follower is not passing. This is the offset distance. Okay. Now how we are going to draw? Let us begin. First, as usual, divide. First step. What is the first step? Okay. Before that, I have to say. So far 4 steps I said. After that, 5th step. What is the 5th step in this year? Marking, dividing. After that, marking the points. That is the 5th step. And the 6th step is joining the curve. That's the 6th step. Now, coming to what is the first step here? The first step is draw a base circle. Radius of 50 millimeter is the base circle. Step 1. The base circle we have drawn. Okay. That is step 1. Well, next step 2. We have to draw the axis of the follower. Okay. How to draw the axis of the follower? First, take what is the offset by 20 millimeter. Take 20 millimeter radius, keep the center here, center of the cam, keep the center of the base circle, draw a circle with 20 millimeter radius. That circle is known as offset circle. That is the step 2. Step 3. Draw a axis of the cam follower. This touching this cam surface, draw a vertical line and mark the point on the base circle circumference. That point is the contact of a knife edge follower. Now it is the point of contact. Now join this point of contact knife edge follower to the center of the cam, center of the base circle. This is the reference line. With that reference line, divide this base circle into 60 degrees. This is the 60 degrees. And again, after that, 30 degree. After that, again 60 degree. Because this 60 degrees thread outstroke, 30 dwell during out, and 60 degrees return stroke, and remaining is 210 is the remaining dwell during return stroke. Now, important is that, very important, divide this outer stroke on the circumference of the base circle into 6 equal number of parts. Because the displacement diagram, outer stroke is divided in how many parts? 6 equal parts. The same equal number of parts you have to divide circumference of the base circle into equal number of parts. 0, 1, 2, 3, 4, 5, 6. Okay. Similarly, divide the circumference of the base circle of a outer stroke with the equal number of the displacement diagram return stroke parts. Yes, return stroke also you have to divide. That is, divide this, which parts here? This is the zone. That should be divided in equal number of 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Now, very important. In previous case, the axis of the cam, axis of the follower is passing through the center of the cam. Now, here it is not passing through. What to do? We have to draw a tangent lines. Which is the point here, the intersecting the axis. Through the tangent surface, the lines should be tangent lines. Here we have to draw tangent line should be passing through the points divided. So the division points are 1. We have to draw a tangent lines passing through and touching the offset circle. Similarly, passing to the 2, 3, 2 passing. You keep the scale such a way that it should pass through and at the same time touching the circumference of a offset circle. So like that, divide. Similarly, we have to follow clockwise motion. Okay, one side like that, another side in opposite direction. No, we are following and division like that. We are coming like that. Okay, you have to follow in only one direction. Again, 1 dash passing through all the lines. Which should, these tangential lines are passing through the division points of the base circle, and it should touch the tangential surface of the offset circle. Divide this. You have to join the, draw the tangential lines. Now, very important, next step. This is the third step. Third step is divided, outstroke, return stroke, and we have draw a, that is the fourth step, division of the circumference. Sixth step is drawing a tangential lines passing through the offset circle, tangential to the offset circle, passing through the division of the base circle points. Next, take the distance from 1 to B, 1B. This is 1B, 1 to B. Take a distance from displacement diagram. This is a point 1 on the base circle and draw a B point. Compass 2 to C, 2C. Next, 3 to D. This is the point 3 and it is D. 4 to E. This is the 4 and cut the arc E. 5 to F is the 5 and it is F. 6 to G, the 6 and it is G. So similarly, we have to mark the lengths of the points, vertical distance of the points from displacement diagram, and mark it on the base circle circumference, radius, tangential lines. So this is a TH, this is a T to H, from T to H. Similarly, J, K, L, M, N, P. After this marking points, we have to join all these points with a smooth curve. So let us begin. This is the dwell zone. There is no division. Complete it. This curve is the offset curve. This is a cam profile of a offset by 20 millimeter of the follower. The follower is offset by 20 millimeter from the axis of the camshaft. From the axis of the camshaft. Okay. So we can see the cam profiles. We can compare what is the shape of a cam profile, what is the geometry, and what is the shape of a cam profile during offset, and also zero offset or non-offset conditions. This is the shape of a cam profile. It is for non-offset condition, and it is the shape of a cam profile during offset by 20 millimeter. You can see that clearly. Offset and non-offset conditions of cam profiles. So it is very important to draw the cam profiles, offset motion, and during offset motion, what is the maximum radius of the cam? That is a question you have to find out. Okay, what is the maximum radius of the cam? What is the maximum radius? The minimum radius of the cam is 50 millimeters, and what is the maximum radius of the cam? You have to find out. Okay, that is your question for you. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.